Hello again, everyone. Welcome to your second AP Calculus video. The second video is on graphing piecewise functions using known functions. So you guys have probably been graphing most of these functions for a pretty long time now. So we're going to do just a quick review of them. So y equals x you guys should recognize as a linear function. All right, and we start at 0, and we're going to go to 1, 1. And -1, -1, and we know that that is a straight line. Okay, the absolute value of x, again, starts at 0, 0, and still has the point 1, 1, but now it has the point -1, +1. Really what's happening with an absolute value graph is we are taking these negative x values and we're just moving them up to make them positive. So this is that nice V graph that we see a lot. Okay, again, you guys should have some straight edges. I'm sorry for those two at least, and I don't have mine. I'm really sorry about that. X squared, we know, starts at 0, 0 and has 1, 1, -1, 1. And it also has 2, 4. 1, 2, 3, 4. And -2, 4 as well. This is that parabola, U-shaped. And then it goes off. Y equals x cubed starts similar to y equals x. We use 0, 0, 1, 1, and -1, 1. But instead of being a straight line, this is the one that curves down. Ms. Vasta refers to this one as the disco function because it looks like somebody doing the disco. Y equals the cubed root of x is really just x cubed, but on its side. So we have 0, 0, 1, 1, -1, -1. But now instead of going off, this one is going to come down and around like that. Y equals 1 over x is the inverse function, so that you should recognize as having two asymptotes, a vertical one at x equals 0 and a horizontal one at y equals 0. It has the point 1, 1 and -1, -1, and then it has two branches. 1 and 2. 1 over x squared is similar. It also has two asymptotes, a vertical one and a horizontal one. But it still has the point 1, 1. And now it has the point -1, +1. And it has its two branches, but they are both going up because of that x squared on the bottom. So all of your values are going to be positive. So they are all above the line y equals 0. The natural log of x has the point 1, 0. And it's got a vertical asymptote at 0, and then it grows very slowly as you get bigger. E to the x is an exponential function with a base e, so we have the point 0, 1, and it has a horizontal asymptote at 0, and then it shoots up. The square root of x, we know, starts at 0, 0, and then has 1, 1, and it also has the point 4, 2. And it goes off to the right. Y equals y equals the square root of 1 minus x squared. Still has that square root, but now because it has an x squared on the inside, this is actually a semicircle with a radius of 1. All right, and we're only looking at the positive. So we have those 3 points, 1, 0, 0, 1, negative 1, 0, and we've got this little semicircle. The sine function, you guys should know, starts at 0, and then we go to the max, back to the middle, to the minimum, and then back to the middle. And we can go backwards as well, so we could go down, middle, up, middle. That is our basic sine function. And it just bounces back and forth. Cosine is very similar to sine, it's just sine shifted over. So instead of starting at 0, we actually start at 1. And then we go to the middle, the bottom, the middle, and the top. And we can go the other direction as well. We can go to the middle, the bottom, the middle, and the top. And we can connect those in our nice cosine curve. Next we have the tangent function, and the tangent function always has asymptotes. All right, and the asymptotes are always at pi over 2 and 3 pi over 2. Same with the negatives, negative pi over 2 and 3 pi over 2. The nice easy way to remember that is tangent has asymptotes. Oh, I hope you guys can see this okay. Sorry. Tangent has asymptotes whenever cosine equals 0. So we have the cosine function here, and wherever it equals 0 is where we have asymptotes for the tangent function. Any place that it doesn't equal 0, we're going to have, any place that it doesn't have an asymptote, we're going to have a 0. So at negative 2, negative pi, 0, pi, and 2 pi. And this looks almost like a cubic function. But it's lots of them over and over again. Because just like sine and cosine, it repeats itself. So at negative 2 pi, it's going to be going up, and at positive 2 pi, it's going to be going down. Okay? Tangent inverse is pretty much tangent on its side. So we're going to have asymptotes at pi over 2 and negative pi over 2. And we still have the point 0, 0. And then it's going to curve towards your asymptotes, like that. So it's almost like a cube root function, except that it's trapped between negative pi over 2 and pi over 2. All right, so we are going to use all of these different graphs to help us graph these other ones. Negative 1 for x less than 0 and 1 for x greater than 0. We know that these are going to be horizontal lines because they are just constant functions. All right, so negative 1, we're going to have an open circle at 0 or at 0, negative 1. And then we are going to go less than, so that would be like this. And then this is also going to be a horizontal line. And I have an open circle at 0, 1. And we are going to go greater than. So that one's pretty easy. All right, we just know that those are horizontal lines and we can draw them in there. For f of x equals x minus 2, when x is less than or equal to negative 1, and x squared when x is greater than negative 1, we know that negative 1 is going to be kind of this point that we want to focus on. Or I'm sorry, not the point, the line that we want to focus on. So I'm going to draw a really lightly dotted line at negative 1. It should not be part of our graph, but it kind of helps us. I wish I had a pencil because I would do it with a pencil, but I don't, sorry. All right, negative 1 is included in this function, the x minus 2, which we know is a line. So we're going to plug in -1. We get -1, -3. So -1, -1, 2, 3 is going to be a closed circle because it's included. And we know that this is a line with a slope of 1, and we want the values that are less than or equal to -1. So I want values on this side. To make it a slope of +1, it had to have gone there and there. And it is going to extend to the left. All right, don't get thrown off because it's a +1 slope. Don't go to the positive side. All right, then we have x squared for x is greater than -1. Well, if we plug -1 into x squared, we get +1. So we're going to have an open circle at -1, 1. And then we know that this is a parabola, so we can include 0, 0, 1, 0, 2, 4. It's much faster than using the tables. We save ourselves a lot of time. All right, then we've got this sine function for x is less than or equal to -π/2. Well, we know that at -π/2, the sine function is -1. And then we know that it goes up and up to the max and back down to the middle. And that is a closed circle at -π/2, -1 because it's included. So we know that this goes here, and that technically keeps going over here. And then tangent, we know that there is actually an asymptote at π/2. So we're going to draw in our asymptote. It's okay to have a closed circle there because that's telling us the sine value. Here, tangent is only greater than π/2. So we want the asymptote there as a guide, but it's okay to actually have that closed point from the sine function there. Then we have another asymptote at π/2 and 3π/2, and we can draw in the rest of our tangent graph. Much easier than having to make a table of values for a sine function or a tangent function, right? All right, we've got one more example we're going to look at really quick. Sorry, I know this video is a little long. All right, so x squared minus 1 for x is less than 1. We know that that's going to be a parabola. All right, so I'm going to do this one in pink, and it's going to be our parabola. And we want x values less than 1. Well, if I plug in 1, 1 squared is 1 minus 1, which is 0. So I'm going to have an open circle at 1, 0. And then this is a parabola that was shifted down 1, which means my vertex is at 0, -1. And then I can go 1 to the left and up 1, and then over 2 up 4. 1, 2, 3, 4. And then I can go over 3 and go up 9. So 5, 6, 7, 8. Here we go. And that is my parabola there. And I can connect the dots. Okay, then I know that from 1 to 3, 1 included and 3 excluded, I just have 4. So that's just a horizontal line at 4. So I'm going to have a closed circle at 1, 4, an open circle at 3, 4, and I have all the points in between. That's my horizontal line. And then I want to do the square root of x plus 1. So I have to do, or I'm sorry, the square root of x plus 1, yeah. So I have to do the square root of 3 plus 1. So the square root of 3 is roughly 1.73. And then I want to add 1, so 2.73. And that's going to be an open circle at 3. So 1, 2, 3, 1, 2. We know it's going to be a little bit less than 3. So we're going to have an open circle. But now I want to pick values that I know I can evaluate. So if I plug in 4, the square root of 4 is 2 plus 1, that's my 3. So 1, 2, 3, 4, 1, 2, 3. And then square root of 5, square root of 6, 7, 8. Oh, 9 is a nice one, right? So let's do the square root of 9, which is 3, plus 1, which is 4. So we have the point 94. So we can connect those there, and it goes off. All right. I hope you guys are enjoying your summer and that you are excited to start your senior year. I will see you guys in just a few short weeks. Enjoy the rest of your summer. Bye.